This is the continuation of the last video that I did on object detection, where I talked about intersection over union. If you haven't checked it out, so check in my playlist, and it might be showing somewhere in the flash button also. I in the last video we talked about intersection over union, where I did this code and try to explain what is happening when we have the boundary boxes and the labels. So this is in this video the same code that I used in the intersection over union video will be used as a part of this video. So not entirely, it will be depend on the IOU, but if you haven't done the IOU, then you will not be able to complete this. So in this video we are talking about the Nomax suppression, as I already mentioned about. And imagine a scene filled with objects, a crowded street or a bustling market, and let's say hard bazaar, example. So when you are in such crowded street or crowded place, and you want a computer vision system to identify all the objects accurately, but what happens when multiple boundary boxes overlap, and you can't decide which object is truly there? So for a single object there can be multiple boundary boxes, and we have to decide, we have to find out the right boundary box that detect the object that we are intended to. So in that case, Nomax suppression or no maximum suppression or non-maximum suppression comes to help us and enhance the precision and make our computer vision models smarter than ever. So I have a little video on that, and if you look into this, so this is let's say we have to detect this car, and our model, what our model did was it calculated, detected the car with three bounding boxes. So all the boundary boxes have certain probabilities, and that probability says that it is able to say that the object lies within this boundary boxes with certain probability, right? So what we need is, we need to find the exact boundary that detect the object. So after the Nomax suppression, we get the boundary box that perfectly, and we can say perfectly, but that detect the object. So how we go from this to this is using the Nomax suppression, and the logic behind the Nomax suppression. Non-max suppression is that all the boundary boxes that our model predict has the probability, and first we have to select only those boundary boxes whose probability is greater than a threshold value, that is hyperbinary. You can choose it arbitrary. Let's say we have chosen the probability to be 0.6, 0.7, 70, 0.8, and that means 70-80%. So first we select only the boundary boxes whose probability is greater than the threshold probability. After that, what we do is, we found the greatest one of those boundary of the we found the boundary box with the highest probability among the remaining one, and we calculate the IOU, intersection over union, of the highest probability boundary boxes with the remaining boundary boxes. And after calculating the IOU, if the IOU is greater than a certain threshold, the next threshold of the IOU threshold, and if the IOU is greater than threshold, we don't keep that boundary boxes, stating that the original and the boundary box with the highest probability, and the another boundary boxes is representing the same object. And if the IOU value is less than the threshold value, we only keep those boundary boxes, stating that it is detecting another object. So that's the main idea behind the Nomax suppression, and I also have a code to visualize these boundary boxes over a random image. So we try to do all that in today's video. Let's dive into the code. So for that, what we do is, let's first import the libraries that we need. So let's import numpy as npm. After that, let's import cb2, and since we are using the iou.py, what we do is, let's import that also from iou import intersection over union, that is the function. So let's create a function non-max suppression and in this function what we are passing is a parameter that is prediction. Predictions, all the prediction boundary boxes, and IOU threshold, TSRES, IOU TSRESSOLD threshold. And let's keep 0.6 as default, right? So we can change it. So after that what we need is we need to find those predictions. We have to first sort all the prediction, right? Sorted all the prediction from highest to lowest. For that we can use sorted function, and we pass predictions, and the key will be lambda x, and that will be based on first value of the array. Reverse is equal to true will get the highest probability boundary box from first. So if we see predictions is equal to what we have is bunch of arrays with 5 parameters: 0.5, 1, 2, 2, 3, and 4. So what 0.5 means is the probability of the probability of the detecting the right object, and 1, 2, 3, 4 are x1, y1, z1, and x1, y1, x2, and y2, the boundary boxes points coordinates, and same is repeated in this array and that array. So so based on this, so we are sorting based on the probability, and so we are using the first element of every array. And after this what we do is let's create a list, final prediction empty list, and for each inferiority predict. So what we need is um, if the probability is greater than, let's say let's do what we did, let's say here probability threshold is equal to, let's say, 0.6, right? So it's greater than 0. Okay, is greater than probability threshold, then only we append that into the final prediction. That append yes, it's so. And so we need the greatest boundary boxes, the boundary box with the highest probability, right? So to make it as a original prediction, that will be calculated against the IOUs of all the remaining boundary boxes. So what we do is predicts is equal to final predict, that is the first will be, since it is sorted, the first will be highest probability, and we take only the 1 to 5th value, right? So after that IOUs, and let's create another array, and for I in range 1 to len final prediction, since we are only using from first, because the because 0th element of the final prediction will be the this one, right? So we don't need to calculate with same boundary box, so we are not doing that. And IOU is equal to intersection over union, and boxes prediction, and boxes levels. So we haven't put boxes levels. Levels is equal to final prediction, that is for every ith element we take 1 is to 5th, the remaining one, and boxes levels. So in this way we get the IOUs. So let's print IOUs also. IOU. So after that what we need is we need to again measure the IOU. If the IOU is greater than threshold, and add to the list, else discard it, right? So we do the same. So for that, if IOU is sorry, if IU is less than, the AI is making sometimes mistake. If IU is less than 0 point threshold, another IU threshold, then only we keep that, else we discard it. That is IUUS dot append, that is we get final prediction I, right. So that's all from the Nomax suppression part, and for that let's try with a random prediction. So I have a random piece of prediction arrays that I am just trying to copy and paste, uh, and after that try to what we will do is we print the IOUs, right. And what we can also do is print IOUs also, right. Sorry, let's print, sorry, print print IOUs, and let's run this function, and after that python 3 nomax suppression dot py. Yes, it has given all the these are all the remaining boundary boxes of the final whose threshold is less than the IU threshold. And these are all, since I don't think any of the prediction is greater than IU threshold, we have maintained 0. So let's do 0.4 as IU threshold, right. So I think this should not be present, and let's do that. Yes, one array has been reduced. So that is the case we had, since these are all the random prediction arrays I have created, and so the result is having all this, but we can change this array and we can get a different result. So after this let's do something else also. Let's draw boundary boxes to a random image based on this prediction, and see what changes we can feel after applying the Nomax suppression on this prediction boundary boxes. Let me create a new function, draw boundary .py, right. So let me do something. After that let's draw boundary. For that let's import cb2, and let's import numpy as np, and after that img. So for that I need one image, and I took this image. So img path is equal to, so I am using this random image, and let's do function draw boxes, right. And for that it will take a image and boxes. So image, and for box in boxes, our box has 5 values. So first will be probability, second x, y, width and height, right. So probability, x, y, width and height are the 5 things that will be come out of a box, since you have 5 values, right. So probability, x, y, height and width. And after that let's create a rectangle with image, and it will x, y, and it will rise up to x plus width and y plus height. So let's color it as 255 and 0. And after that what we do is let's put text in that boundary boxes. So put text, and that will be image, that is str, uh, that will be probability, right? So we have to as a text we are only passing the probability values of each of the boundary boxes. So that will be x y minus 10 and cb2 dot font is simply say it's this simplex. That's the font family we are using, and 0.7 transparency and 0 0 and 255 for the color. After that, let's do another rectangle x y x plus width y plus width y plus width. So 0 0 2 5 5. This is for filling the boundary boxes. And after that, what is this written image. So in this way a boundary box will be created for an image, but we have to since there are multiple borders, so for that we have to multiple borders has to be displayed. Let's create another function. So border emg path and boxes, and that will be image boxes, and let it be draw boxes, and that will be image path boxes, and that let's do cb2 dot that I am so image with boxes, and that we need to pass image boxes, right? And cb2 dot weight key, let that be 0, and cb2 dot destroy all windows. So if you press any key, then the windows will be shut down. Since we have created this function, let's import in these since the prediction value is here, so let's do this. So we need what we need is we need let's copy these predictions, and just simply what we do is pass show border boxes, right? And what we do is let's import this from there, and also let's import from draw boundary import show border, right? And what we need two parameters, that is image path and boxes. This function will show all the image with the initial given all borders. After that, after applying the IOU this Nomax suppression, we get the limited number of boundary boxes, and we can also draw boundary boxes over that. So that is so border img path and IOU. Yes, I think we are done. Let's save all the files and run it. So let's not print anything for now. I don't think we are printing anything. Yes, let's test the moment of truth. Sorry, I think and 5, I think we have, I think there is a problem right here. I don't know, but yes, we have to put this also to here. I don't know what is happening right here. Express. Let's CB2 either bad argument function rectangle. Image x plus y x plus with 0 minus 1 and rectangle image. Oh, sorry. I have mistaken here. I think it should run fine, right? Not again in the rectangle. I'm not able to. Y plus height HEIGST x plus width, and that is right. Image is equal to image dot copy. I don't think that is also creating any problem. XY width height, that is right. Uh, 0.70025552. Let me replace this, and I don't think we have anything else to. STR object has no option copy. We're just passing the image, right? Image path. Oh, sorry. I think the problem is, now I think I found the problem, and we have to pass it here. img path, since we have not passed in, and again what we do is img underscore path. Let's do that. Image dot copy. I think it should have worked perfectly. Sorry, I haven't read it. Image cv2.im read. I have to do this, right? Yes. This is the initial the random pixel with the initial all the boundary boxes, and these are 0.78, 0.81. These are the probability values, and after applying the, so this is the initial. So if I do Nomax suppression over this, so I get these results. So these are the boundary boxes, and that are only captured after the Nomax suppression. So since the prediction levels or the prediction array are randomly generated, so it doesn't make sense as of now, but I think you have got the idea about the Nomax suppression and the intuition what I am trying to show in this tutorial or from this diagram. So it only take the boundary boxes whose IOU is less than the given threshold, and the IOUs with the boundary boxes whose IOU is greater than threshold are eliminated, and only the boundary boxes with highest probability is taken. And that is one of the matrices that is used in computer vision object detection. And I think you have got the idea, and see you in the next video, and thank you for watching my video. Thank you.